G'day viewers, and welcome back to the channel. Now, getting our clients to review our detailed black and white drawings seems to be an ongoing problem and becoming more and more difficult. This is where I feel that Omniverse might be a new way of engaging with our clients to have them review our designs before we issue them for manufacture. As we all know, reissuing drawings after the fact is just a right pain in the backside. Thanks for Adrian McGann, I hope I've got that right, mate, for his request for doing a video on the Omniverse. If you don't know Adrian has a channel on YouTube as well. It's called ErCAD. It's a great resource for finding more content and tutorials on advanced steel, and it should be used by all. I use it myself to refresh my memory on certain features that haven't used for a while. So do yourself a favor, have a look at Adrian's channel and subscribe and watch his content. I hope this video will provide an insight as to where the Omniverse will sit in a modern construction documentation world. I hope that my research after spending weeks looking into this will actually provide you some insights of how best to incorporate this into your workflow. All right, let's start with what the heck is the Omniverse? Well, it was built by Nvidia. It's a platform and it's not an application. It was originally developed for the visual effects community or that industry, but has now been gaining support with people working with digital twins and in the construction sector. It's not that old, so don't feel bad if you haven't heard of it before. It was only released as an open source project in around 2022. It uses a framework called OpenUSD. OpenUSD stands for, or the USD part stands for Universal Scene Description, which is all about describing how a stage or a scene from a movie is set. The open part was added to the acronym USD because USD in Google searches will bring up the US dollar. It was originally developed by Pixar. So Pixar is a Disney company, and it was originally developed for their internal teams or their internal departments to help their teams collaborate on projects. So they would have people who are working on lighting or cameras or character animations, and they needed a platform to bring all those teams together. So they used a framework called OpenUSD to share information from one software application which a character animator might be using and another application which a lighting member might be using. Think of OpenUSD as something similar to the IFC framework that we use in the AEC industry. Okay, so what do we know so far? We know that the Omniverse is a platform and it uses the OpenUSD as the framework. Okay, so what else do you need to know about the Omniverse? It has a central database. So that central database is called the Nvidia Nucleus, and that database can reside on your local C drive or it can reside on a server. Okay, that brings me to the question of cost. What does it cost? Well, the Nvidia Omniverse is free. Well, when I say free, it's free to a point. It's free to collaborate with one other person, so you can have two people who are collaborating on the one database. That part is free. As soon as you start getting past that and you have a team of 5 or 10 or 20 or in some cases 500 users working off one database, well, there are costs and licensing associated with that. It's not exactly cheap, but it's a very powerful platform. So my advice to you would be to use the Omniverse free platform or the free level for as long as you can. Well, that's probably enough background and context to what the Omniverse is. We should probably now go in and take a look at what is it and showing you where to find some of the features. To get the Omniverse, you will have to first download the launcher. So let's take a look at where you get that. Okay, so here we are in the Omniverse Nvidia website. If you were to Google Omniverse getting started, this page will probably be the first page that will come up. So if you come into here, you will see there are 3 levels, and there is a standard. This is the free one, which you can have 2 people that are working. We have the enterprise and the cloud. Now, once you start getting into these realms, best you have some deep pockets or save up some pennies, because there are quite a few. It can cost quite a few dollars to have those large servers running. So the free one, you can see down here, multi-user collaboration and live editing, up to 2 concurrent live editors. So as I understand it, that will mean that yourself and one other person can access the database, which is the Nvidia Nucleus, which is the database system, and you can be working collaborative in that space. Once you move away from that, then you have to start buying licenses, which I haven't been in touch with Nvidia yet, but what I've read on the forums, it can be a couple of $1,000s per seat per year to have access to that. So anything that you can do in the free world to get yourself up to speed would be a wise choice. So downloading this will download the launcher. So let's take a look at what the launcher is, so you understand what that desktop application is all about. So we'll just close down this browser. Okay, here we have the launcher. This is an application which runs on your desktop. So I've got one here, so I can start it from here. I'll just maximize that. So across the top here, we've got some different tabs. We've got the news. I can bring that up. It's just having a think. There we go. Sorry. Here we go. We've got some news. So this is like a newsletter that brings up some news articles which you can keep on top of new features that they're adding. There's a library, the exchange, the nucleus, and a great resource here for learning. So we'll just let it come up. So what it doesn't actually have is a search tool. I haven't found a search feature yet. So finding the right tutorials that I want to learn, I haven't found that as yet. But there's a whole bunch of videos that will talk you through how to find stuff. I've managed to get myself up to speed relatively quickly. It's just a matter of trying to find the right information, but a great resource here for learning. Okay, so I've whizzed through that pretty quick. Let's go back and have a look at some of these things. So the nucleus. So the nucleus is the database that you'll work from. So it's like a server. It's like a OneDrive or a SharePoint. It's sort of a repository of your project information, which will be your models or your textures or your animation files, all that sort of information in one place. That is what it is. So you can see here I've started some projects. So I've created a folder here for YouTube, which is some practice files and folders that I've put together. So we'll have a look at that to sort of get an idea of where we're going to go today. And I've created a couple of folders for today's video to show you the 2 methods of getting from Advanced Steel across into the Omniverse. So we're going to take one track that is from Advanced Steel to Blender BIM into the Omniverse, and then we'll take a look at going from Advanced Steel through Revit into the Omniverse. And these are two pathways that you can take to get to the Omniverse, and there are different use cases to which one might be most suitable for your project or your application. Okay, so we know that loading a nucleus or creating a nucleus on your hard drive is what you will need to do next. So there are some videos out there to talk you through that. So if you understand what the nucleus is, it's a key part. It's the central part of the Omniverse for your file exchange or your file storage. We'll just come back. We'll come back to Exchange. We'll just show you briefly the library, because the library is where things will end up. When you first load the launcher, you won't have all these things that I have in my apps and my file management and my connectors. You won't have them straight out of the box. You will need to use the Exchange to get the library information or the library applications there. Okay, so what's in the Exchange? So the Exchange has apps and content and connectors which you need to have as part of your Omniverse experience. So if we have another look here at what is in the apps. So the apps are tools that you interface with, and you can actually build your own interface. The Omniverse kit here is a toolkit that you can actually build your own user experience. So you can have your own dialog boxes and you can build your own app. I wouldn't advise going straight to that point, but that is the flexibility that this platform actually has. So I would be recommending that when you first get yourself up and get your launcher running, you would want to download the Composer. So the Omniverse Composer is where I've been doing most of my work, which is, in some videos it actually calls it the Create, which I haven't quite got my head around yet, but I think there must have been a name change at some point, and it's now called the Composer. But essentially I'm using it for bringing all my models together and setting up materials and cameras and all that type of work. So I would say you would also be using that as your main sort of gathering point at this time. I would say the navigator is important. That is almost like a file explorer for your nucleus. The USD viewer, people have said it's it's good to have. I haven't found a use for it yet, but I would download that. The Omniverse cache, I would download that. That essentially stores information to access easier. So I would definitely download that. The Omniverse kit I wouldn't download straight away, but understanding what it can do will be important. The Omniverse Explorer I downloaded, I tested it. I've found that the Composer is better, but the Explorer is a bit like using Google Maps to walk through a project. So I haven't found a great use case for it yet. However, you might. So I would download it and have it in your library. These ones I haven't used as yet. Definitely the Blender 4.0 Alpha USD branch. This is definitely a must-have. So this is a special build that Nvidia has done to allow the Omniverse to connect to Blender. So they've created a special build. Depending on your knowledge of Blender, Blender is an open source application which can fork off different code from the source application. In this case, Omniverse has created a fork in the source code to allow the models that you have in Blender to be exported across into the Omniverse world, and we'll see this later on. So there'll be a two-part process that we do. I will be exporting the IFCs, importing that into Blender BIM as an IFC file and saving it as a Blender file, and then opening up that Blender file in or with the special build that Nvidia has made for this purpose. So we will get to that. So that's a definitely must have. The Omniverse USD presenter. So this one, I would say it's a must have. I haven't found all the use cases for it yet. However, is a great tool for marking up. So you can have your models and share that with the people you are collaborating with. But I believe you can only have two of these people or two collaborators at one time using the presenter. I'm not 100% sure on that, but I understand that is the rule around that. However, you can have other people, well, as long as there's two concurrent people. So I still got to do some testing in this space, but there are tools there for people to walk through your model, point to objects. It might be a beam or a piece of concrete or something, that a handrail that they want moved. They can comment on that in the model and give you some feedback about the model. So this is where I believe the value will come with this particular platform, to allow your clients to interact with your model earlier in the process, so they're not waiting for black and white drawings to show up. Okay, so that's the presenter, the scene optimizer. I believe that you will definitely need to have that. The Omniverse drive, they say it's in beta, but what that actually does is allow you to create like a map drive of where all your Omniverse files are, to make it look like a map drive, even though it's not actually a copy. It just is a showroom I haven't touched yet. The creator I actually downloaded, thinking that I downloaded it and I added it to my library, but I've tended to use the composer and not the creator. Omniverse streaming to client, I have no idea, I haven't touched that one yet. How we interact with the clients is definitely what we're about, so this will be something I will be looking into some more to see how to utilize that, or if it is what I think it is, in a way that a client can keep an eye on the channel to see what comes of that. Okay, so that there we're talking about apps, and they are ability for us to share from our design authoring tools to the Omniverse. So an example of this for us would be, and we will show you this today, is with the Revit Omniverse connector. So this will download a plugin for your Revit session, and it will allow you to publish or create a live link to the Omniverse. So technically you can be working live in a model, so you can be with a client modeling in Revit and updating their viewing of that model live, and you can turn that on and off, or you can just publish once a day or once a week, how little or as often as you like, to the Omniverse platform. So these connectors are for these interfaces from the design authoring tools to this platform environment. So you will see that ArchiCAD's got a connector. Some of the people who are modeling in Maya, 3D Max, these sorts of spaces, they have connectors to model and then push this information into the collaboration tool, which is the Omniverse. So think of Omniverse as the glue, a bit like what Navisworks does, in that it brings a bunch of models together. This is what the Omniverse does for what used to be the visual effects industry only, but now gathering momentum in the digital twin world for the construction industry. So these are all different types of connectors, and you may have, where did I see here, there was a Trimble one here somewhere I saw. I did see that somewhere. There we go, Trimble SketchUp. So if you're modeling in SketchUp or Rhino, then these tools will allow you to, similar to Revit, push your model to the Omniverse. So that's connectors. Then you get into content. So content, basically like assets, like libraries. What have I downloaded here? I've downloaded the automotive material pack. Why? Because I thought, some pretty paints might come in handy. The V material, downloaded it. Base material, downloaded this. They are just my base material and textures at this point in time to get myself up to speed. So these are all asset packs. I would definitely have a look at some of these. You probably don't want to download them straight away. You may want to add a few to get started. You can always come back and download these later on. Some of them are quite large, like they can be 20-30 gigabytes of size. So it's they will put that in your cache. So it's not like small packages. They're quite large. So which ones have I done? So I've done all the materials. I did the environments and skies. I did some warehouse ones. The industrial one, thinking, okay, I do industrial type projects. I did a commercial one as well. I haven't done the city, although I probably should. So I've done that. The extensions are, I see them as third-party applications, which at this time I haven't really added any of these to my system yet. So this is what the Exchange does. It's like a place to download your applications, connectors and content. And once you've done that, it will show up in your library. So you can see here I've got the Blender tool, I've got the Create XR, which I'm not really using that much. I've played around with it a little, but not greatly. The USD Composer, which I'm using most of the time at the moment. The Explorer and the Presenter I've played with a little, but I keep coming back to the Composer to do the majority. The USD Viewer I've played very briefly with, but again, the Blender and the USD Explorer have been my go-to applications so far. File management, your caching, your drive beta and your Nucleus Navigator. So if we open this up, you can launch this. It's like a secondary application, and then you can see your Omniverse and then your hosts. You come into your projects. So it's essentially like a file explorer to help you find your tools. But having the drive tool also helps to find your files, so that may not be used as often. So again, you will find your use case. Okay, so that probably covers off most of the library and Exchange. The Nucleus, again, this is setting up your drive and your database, and the learning part is the tutorials and videos to find out how to use it, which you'll enjoy thoroughly, I'm sure. Okay, so we've had a look at the launcher. I think what we should next do is have a look at the USD Composer, and I will open it up and show you some of the stuff that I have been working on or have been testing, so you get an idea of where we're going to go today, and then we'll go back to the start and then show you how to get from Advanced Steel to the Omniverse. So I thought, well, we'll show you where things are going to end up, and then take you back to show you how to get there, so you've got some idea of where we're going to get to before we start. So let's have a look at some examples of where we're going to head today. So we'll launch the Composer through the launcher. That's probably why they call it the launcher. You can have a read up on here and what it's all about. The Omniverse USD Composer is an application built on Omniverse Kit. So Omniverse Kit is the tool that builds the interface that accelerates advanced scene composition and allows users to interactively assemble light, simulation and render scenes in Pixar's USD in real time. USD Composer lets you easily navigate, modify and render Pixar USD content in a live environment. Okay, so that's what it is. Let's launch him. So this is the interface. We'll just maximize him. So when we talk about the kit, all these little dialog boxes around the outside, all this is customizable, and you can actually build your own interface if you want. Okay, so we're in the Composer, and we'll just open up a USD file. Let's go to projects. Let's go to my YouTube, which is my test environment, and let's just open up a model. Let's open up this one. So this is something I made up for the thumbnail for the YouTube screen, or the thumbnail for the YouTube. This is a model that's been created and pushed into the USD, and okay, so that sort of gives you an idea of what this can do, but it's all about real-time ray tracing. So it's allowing me, you may not be able to hear it, but my GPU has just gone crazy. So if I now take you across to one of my other screens, you can see here my GPU is gone off the chart. It's running at 81 degrees. It's working overtime. The CPU not working that hard, but right now, because of the work that it's doing, it's working overtime. Okay, let's just go back to start a new, they call them stages, a new scene. So here is a new scene. What we can do is we can bring in these models. So at the moment we've got an empty scene. There's very little in there, so let's just drag and drop some of these models into this environment. So let's drop that one in there. So you can see, a bit like Navisworks, it allows you to bring models into a coordination space. What have we got here? We got 5. Okay. So you can see now that we've got 5 models in this space. And we can zoom in. This one here, I've actually put some materials on. These ones over here, I haven't. But you can see the level of detail and the ray tracing that is actually happening in this space. And if we look at the environment, so let's just get rid of some of the lighting in these spaces. Let's just get rid of lights here. We should be able to drop in a new some new lighting and delete that. Drop in a new one. I'm just getting rid of some of the environments here. That will give you an idea of what we want. So we can now just close that down, save that. So yeah, so that gives you an idea of where we are going to go. So I think it's now time to go back to the start. So we'll go back to Advanced Steel and we'll take a look at the process from Advanced Steel and the process to get to Omniverse. Okay, so here we are in Advanced Steel, and this particular session of Advanced Steel, I have those 5 models, and I've got those 5 models X-referenced into my project, and I use the _00 to bring those all those into one place. So these are X-referenced files. I've also got each of these X references open as individual models. Now I'm doing this to sort of replicate a project where you have multiple work areas on a particular site. So what I'm trying to demonstrate here is you have a project, and in this case we've got 5 different work areas. So if you were to consider this project like a school, maybe, where you had a school and there were 5 buildings that needed detailing. So that is what we're trying to replicate in this particular sort of demonstration, is to say we've got one project with 5 different work areas in my Advanced Steel system. For each one of these work areas, say here, that's a work area, I can have 6 lot and phases based in that area to break down that particular model. So before we go too much further, I'll just go through and delete any of the IFC files that I've created in this area. So just give me 2 seconds to go find those files in my, I call this a sample project. If I go here and I can delete those IFC files, so we're starting from scratch and we will recreate those. So let's just go to this first one and we will create an IFC file. Let's just go to the area where we are working. We are in the sample projects in CAD, and I'm going to save this file here, and the project is called what have I called this project? Project number 42, and it's work area 1. Right, so that IFC file's now been created. Let's just do the same with the second one here. So we'll put it in, we'll call it 02. So this won't take too long, but we'll get these 5 files exported pronto. It'll give me a chance to have some of my coffee. Looks like this one's taking a bit longer to create. A lot more beams and bolts and plates in this particular model. What are we up to here? This is model number 3. Have a good old think about it. There we go, done. Okay, let's do model number 4. You can see that last model, it was around 100 meg, so it's got quite a bit of information in that. More coffee. Where would we be without coffee? Right, that's number 4 done. The last model. This is a residential house project, and yes, we need to export, and we call that. So this has not actually been saved to the Omniverse at all. This is just saved in my general work environment, so where you would normally store your advanced steel model. So it's not actually storing in the Omniverse at this point. So the idea behind having these different files in the different sort of geolocations, once you start bringing these files in, I wanted to sort of demonstrate how you can use Omniverse to coordinate some of your models, so they're not all coming in at 0,0, but there are methods that you can actually move your models, similar to what you do in Navisworks to coordinate models. Okay. So we've now created those files. So if we come across to my camera 1, we can see we've now created these files, and we've got 4 meg, 14 meg, 111, 36 and 75. So they're the different sizes of the models. So step 1 is to export the IFC files from Advanced Steel into a neutral format. So the next stage, we will open up these IFC files in Blender BIM and save these as a Blender file. So let's take a look at that. Okay, I'll keep the Advanced Steel session open, and I will launch my Blender session. So anyone who's not looking into Blender and Blender BIM, I highly recommend that you get onto some tutorials and get yourself familiar with Blender. Blender is an open source and free modeling tool. Blender BIM is being added on top of Blender as a native IFC modeling file, and it's a very powerful tool. So here we are in Blender, and we are in the Blender BIM portion of that, so I can delete those. So the first thing we want to do is to open the IFC project. So we'll come down here, we will go to those IFC files that I just created, right down the very bottom, righto, and under CAD, under IFC, we have the first one. So let's load that into our Blender BIM application. Okay, here we have the world famous billboard. So this is an IFC file. So what we want to do now is we want to save this as a Blender file. So we want to now change this. We want to move this across. Just go to where I want to go here. Sorry, users. There, projects. Oh yes. So we want to. I want to delete those. So give me a second to delete those. Just go back a directory, go back into Blender BIM. Okay, so I've deleted those. So now I can save this new file as 42_01. So what we are doing here is creating a Blender file. So you have an IFC file which you can add your 4 and 5D information to, which will remain as an IFC file, but that IFC file exists inside a Blender file. So we can save that. So that's now saving as a Blender file. So let's just open up the next one. We'll do this for all 5 of these files. Okay, so we have our second one. Again, save as, save it as work area number 2. Save that. Now open up number 3. That's taking a bit of time to load. Did I get that right? I don't think it's going to crash on me. Just having a good old think about it though. Normally Blender's quite a stable application. It'll probably put the mocker on it now and it'll probably crash on me, but typically it's quite robust. If it does have a hissy fit, it tends to get itself out of a bind and gets itself up and running, but you do get the odd case where it will fall over on you. Okay, so brought itself around, so we'll save that as number 3. Again, it's having a bit of a think here, so it's obviously saving in the background and reopening the next model. Something you'll notice when loading files with Blender, it actually is multi-threaded. When it's not all multi-threaded, but cases like loading a model, it actually uses multi-threading, which is very innovative for a software vendor to use some multi-threading processing to speed up our day. It's just saving again. You can see here all that green, all that multi-threading going on to load up this next model. Still loading, getting warmer. Righto, now she's loaded, so we can save that now. Save that as model number 5. Righty ho. So that is step 2. So step 2 was to open up the IFC files that we created and save those files in Blender. Now, you could do additional work in the IFC file if you wanted to append the 4D or 5D data into that IFC file. So where I see this become really valuable is using the Blender BIM tool to add your timelines to your project, so you can animate your construction sequence. So by putting that data in those timelines in Blender BIM, you can use that information down in the Omniverse later on to create your animations. Or you can actually create your animation in Blender, animate it there, and share that with the Omniverse. That's the power of this platform. You've got multiple areas in which, and multiple ways to use your data. So we've now got the IFC file, we've got it into Blender, we've saved it as a Blender file. Now we want to get it out of Blender and push it to the Omniverse. Now, this is where earlier how I spoke that Nvidia have created a fork in the source code of Blender. They have created a special build of Blender which we can open up and export the models. So let's take a look at that. Okay, so here we are. We're still in the original the original Blender session. So we can close that down now. We can minimize that, and let's just to save some resources, let's just close down. Actually, I'm going to leave that. No, I won't need it because I've created the IFC files. We can always come back and close or recreate files if we need to. You won't save any of these, but it might save a bit of resource power with our RAM. Not that I've had any issues with it. I've had quite a few advanced steel models open and sessions of Omniverse and Blender all at the same time, and it hasn't been causing grief. So that's been good. Okay, so we've now got the Omniverse launcher open, and we'll come to our Blender 4.0 Alpha USD branch. So this is the forked version of Blender, and we will launch it. So it'll look and feel like a normal Blender session, other than it's a special build. Okay, so if we come into here, you can see how there's an Omniverse tab here. So what we will want to do, open up our Blender files. Are they the correct ones? I believe they are. So let's just open up that Blender file and go to our Omniverse exporter. So it'll export it as a open USD file. So you can see how we've got our database here, got our projects. Oh, I need to go back there a little bit. Where'd we go? Sorry, go there, go projects, and these YouTube places where we had our original files. But for this new session, we're going to go this one here for the Blender stream to get to Omniverse. So we'll just save this as project number 042 area 01, and that will create an open USD file of this. Okay, so it's created that now, and it's quite quick. It doesn't take long to export it at all. Let's just do the next one, and we'll bring up the sidebar, go to our exporter, 0042_03, opening up the model 4. Yeah, that's right. Got myself confused there, sorry. We'll export that. B004204. Sorry, when we go N to open up the sidebar. And I think I might have saved these in the wrong spot. I might have to go back and check this, I think. I think I might have made some errors. 42 underscore, well, it's at 05. Okay, I didn't see all my files there, so I'm going to just double check to make sure I've done that right. Blender, yeah, I feel I've been saving them in the wrong spot. Righto, let's amend that, get it right. Well, it seems to be there. Let me just double check in the nucleus here, in the navigator. We'll launch it. 1, 2, yeah, so it, I'm not sure where I was actually saving those. Maybe I was saving them, I don't know. All right, come back to our Blender, we'll get it right. Let's open up model number 2, export that. Yeah, maybe I just wasn't picking the right the folder. So I think number 4 was missing. Let's just export projects, Blender BIM. Okay, it looks like we've got all the files there now. Got there eventually. Let's just go to our navigator again and see what our navigator is going to tell us. Might help if I launch it. Let's try that. 1, 2, 3, 4. Yes, we've got it. We'll use this other folder later on when we go down the stream of using the Revit methodology. All right, well that seems to have worked. So we've now got that across. So we're in Blender here, and we are pretty much finished with that exporting. So we can close down that special build of Blender, and now we can come into our composer, just maximize that session. Let's create a new stage. Okay, so we're now in a session. We'll come down into our Omniverse here. We'll come into our projects. We can come down to our new folder that we are just using now, and you can see how we have the 5 files that we created. So we can now select those and drag those into our session. You can see how I just dragged that in all at once, and we can bring them individually, or you can bring them all in at once. So I've brought them into a stage. So this is something that you'll need to get your head around, is what the Omniverse is. It talks a lot about stages. So if you think about the world of theatre and film and movies, a lot of the terminology will be based around that. So a stage, if you think of what are the props that you need on a stage for a particular shoot. In our case, our stage is our project site, and we have brought our 5 project models to that one stage. There's also a feature that they talk about in Omniverse called layers, and layers are, once you've got your model on your stage, you can then edit. They call it non-destructive editing. So you can have a construction model with all your beams, and then you can do things with it to put it into a different state. So an example of this might be that you have your model in a state where it's constructed, but then you have your same model in a format where it's deconstructed, where you have all your steel on the back of a truck showing the different loads that are coming. So yes, the final construction is your final layer, but you can have that model in, it's called non-destructive modeling, in that the final result will always remain, but you can move the beams independently, which is pretty cool technology, and it's a feature that some of our design authoring tools should probably look into. Okay, so we're back into our session, and you can see that how when we've brought this stuff in, like, it doesn't have any materials, but you can see how like everything's looking white. But we've brought some lights in, so we just might need to bring this in a bit higher up the scheme of things here. So I'm just deleting some lights from the scene, so it's all very dark on us now. Right, now we've got some light on the situation. Okay, so now we've got the light, we can see that we can play around the lighting and we can actually loop that around. So let's just play with this lighting. You can set up, the location, all that type of thing. I've just got it on a loop here to go from 6 a.m. to 6 p.m. and at the moment it's doing real time, but it's not doing any path tracing. So we'll just make the GPU work a little bit harder. But you can now see how it is rendering. So we'll just pause that, and then we can go back to a position that we like here. Let's just get to a point where the lighting is sort of give us a little bit of shadow. Okay, and let's zoom in. So one thing that I've found, and there's a few people on the forum that are talking about this, if anyone's got the 3D mouse, the drivers for the 3D mouse don't work yet in the Omniverse. So there are people on the forums going, hey, this would be handy. I keep reaching for my 3D mouse and it doesn't work. So some things I've learned at the moment is holding down the Alt button and my left mouse button, that will give me an orbit. If I hold the Alt button down and my left mouse button, that will be a zoom, and Alt and my scroll wheel will give me a pan. So it's taken me a while to get around that. I'll just zoom out a little bit with my scroll wheel. Some of the other navigation tools that I've found is right mouse button and W will like dolly me in, and this is some of the gaming stuff that so S will take me out. So anyone who's familiar with gaming, it's left mouse button and A will pan me right. You got to keep holding down your left mouse button, then D, and then Q goes down, and E will take me up. So Alt and left mouse button gives me a bit of an orbit, and my scrolly wheel will get me in here. So you can see how basically it has either apply some materials in the blender space and push that across, or we can place materials in the Omniverse world and push it back, because you can link the files together. So if you make changes to your Blender file, it will then update your Omniverse world. So you'll need to do a little bit of work on the workflows there to push and pull your data and your geometry. But let's just take a look at a few tricks I've learned about how to assign materials in the Omniverse. And what you have to understand is that CAD models typically don't have their objects with their UV unwrapping or the UV mapping. What that is, when you have an object, say it's a cube, to apply these clever realistic textures to these objects, you basically have to unwrap the skin of the object so it knows how to wrap these textures around the objects. Now, CAD models typically don't have UV maps assigned to them. If you are modeling in Blender or in the Omniverse, it sort of knows that you're going to need this, so it automatically does this. But CAD models don't have that. So what I found when and I might just do this now, I will try to apply a material to an object, and it doesn't really work. It will apply a bitmap, which is just a plain color to an object, but with these PBR procedural materials, which are really realistic looking and really create that realistic effect, you have to unwrap it. Now, for our industry, for doing construction projects, we probably don't want to get into the level of detail that others would want to do with their UV unwrapping. We want to get it done pretty quick. We want it to look okay, but it needs to be fast because we've got, thousands of beams and objects. We need that to happen quickly, and we're not so worried about it looking perfect as gamers would want to do. We would want it to look good enough to allow us to interact or share these models with our client and allow them to look at it and say, hey, that looks pretty realistic, and they can appreciate it for what it is. So let's take a look. So we're now back into the Composer, and you can see here I've downloaded the automotive colors, and I can try to, let's just select this slab here and apply that, and you can see it really doesn't do anything, and that's because this big concrete slab, it doesn't have a UV unwrap on there. So let's just Control Z, take that out. So the trick that I've learnt, let's just move that around and come up to our window, and we come to Utilities, Scene Optimizer. We want to optimize the scene, and we want to generate projected UVs, and we want to run that. And it's going off and doing some work. You can actually see that in the background now that some of these things are happening. That well, actually that's probably coming up because it was probably loading the green material into the library. So what it's now done is it's now gone and applied a UV map to all these objects. But what it really means is that these materials will start to become far more realistic looking. Like you can see that that green texture now. We can put a carbon fiber or a red paint. Let's just go find some interesting things to look. What have we got here? Some fabrics or base. What have we got? Some leopard skin. Well, that's a bit dangerous. So what it typically will do is it will have to go off and find all those textures and patterns, and it will then load them into a cache, and then when you load these materials for the first time, it may take a bit of time to get there. We have a concrete. Let's just put some rough concrete in here, and if we go to down the very bottom here, we can make changes to these. So we've got that particular one there, and scale, so we can probably change that to 5, and you can see how that scale change. Let's go to 10, see what that does. So you can see that it changes it. You can see how the concrete now has some decay on it. What about some precast concrete? What does that look like? Not overly exciting, but there we go. So yeah, so we're now capable of putting textures onto our objects. Now, the next big piece to the puzzle to speed up your process is, because we've got our structured data with our materials, we can use that to our advantage in Omniverse by selecting materials or objects with the right material and swapping from a white object to a say for galvanizing. So let's have a look at that. Right, so we're back into in our Omniverse session, and we have to go to Windows and go to our extensions and do a search for swap. And material swap is an extension, and we can turn that on. So we can now shut that down, and we can now we've got our material swap dialog box. So what do we want to do? Let's go delete some of these previous ones. We don't need carbon fiber or the paint. all the animal skins, concrete. We don't want any of those, so we can get rid of all that. So we're now back to where we were. If we go right up the top, let's go to our objects and we'll go to our materials. So we can look at this particular model and look at this particular mild steel, cold formed, grade 350 L0 smart coat. So let's have a look at that. So we can right click on that and say copy prim path. We take that and we paste it in to our dialog box over here. Now we want to go to our materials and we want to look up in all. I want to type in there, let's go zinc. What does that come up with? So zinc galvanizing, there we go. So we want to drag that into our stage, and now we can do the same thing. We can copy the prim path and we can paste that in there, and now we can ask it to swap, and that will swap out those objects. Let's just go to one of the other ones. Let's go to mild steel black. Let's copy the prim path, get rid of that one and swap out those. Let's go to the, where are we here? 250. Let's get that one there. Copy prim path. That's zinc path. Let's just test that again. That one. Copy the prim path. For some reason, that is not swapping over, which is what I was expecting. So I wonder why that is. Which model is that? I think that's the right one. I wonder why that's not working. Let me try that again. Let's. I know why it's not working. I can just swap that down. If you can look down the bottom right-hand corner here, that galvanizing material is still loading that material. So I'm thinking it should be changing over. Well, it hasn't actually loaded that as yet. So it's at 90%. So we'll zoom back out here. I'm expecting that once that material is actually loaded into the cache, that we might get some of this stuff actually changing. It'll be interesting to see whether it will automatically change or whether I will actually need to go back and redo that material swap, or whether it now knows that it has been swapped and that it's done. So we'll just have to wait. We're at 98%, 99. Hey, look at that. Isn't that magic? Look at that. Once that actually downloaded, the material came across, and you can start to see now. Let's just close that material swapping down there now, so you can see how now we've got our real-time rendering happening. And so if you look at that pattern, it's probably a little bit too big. So if we come down to our zinc and galvanizing and look at our texture scales, let's just change that to, and I think I've gone in the wrong direction. Let's go the other way. Let's go to 0.3 and 0.3, and I would say we are probably a little better. So that let's go to our, I'd say that is more realistic. If I was to say anything, I would say that moving to 0.5 from 0.3 is probably a little better. And there's different shaders that we can use. So let's just try some other objects here. So let's change, say, this object here, which is a mesh. So this is a aluminium mesh 6060 T4. So let's come up to our materials, mesh T4, and we can first of all, we'll bring up our extension again. I've turned it off. Swap. Ooh, sorry, my apologies. Windows, extensions. Yeah, that's what we want. We want to material swap. There we go. I had it turned on. I just was unsure how to bring it back up. Righto. So we'll now get our copy prim again. We'll copy this across and let's go find a mesh. This hexagonal mesh, let's drop that into our project. So let's just drag him across and let's not make the same mistake as before. So we can see that that mesh is now loading up at the bottom there. So okay, that's good. Let's now copy the prim path and swap him over. See if we pick the right material. Yes, we have. So you can see now that material. So let's just move him around. You can see that material now is added on, which you can then change colors and all that type of thing. But you can see how using your BIM data of your materials to allow you to filter and select items will speed up this process. Now, it's also important to note that Omniverse is built on a lot of Python code, so that what we should be able to do in the future is have our list of known material types that we use in advanced steel and a library of the preferred textures that we want to use in Omniverse and run a script. So we don't have to manually go through and do this. We'll be able to run scripts, which will then make it very, very fast to convert these white objects with no textures to an object with textures. So we'll have materials for concrete or precast concrete, galvanizing, painted steel. Maybe you'll have a silver one for your bolts, masonry walls, all those sorts of known typical types of materials that we use. We can assign preferred materials to that, script that, run it very fast. These are the sorts of productivity gains that we can have by having structured data. Okay, so that I think is a good starter to explain how the process works. Where do we get? I've got a run sheet here, so let me just have a look at what we've got. Some other things that I've found is the rendering ability. So if you want to get out a quick image here, so F11 will take you into like a full screen, and you can see how it's rendering away and doing some processing here. And you'll also notice that the GPU is running at 100%, so the office is getting quite warm because of the heat that it is generating. So F11 will toggle backwards and forwards. You can see how the heads-up display, we don't really want that in our renders, so we can turn that off. We can hit F11, and now we've got a full screen. Let's just zoom into here, and you can see how fast the real-time ray tracing is producing here. Let's just move that up there. Let's just change some of our lighting settings to see what we can do there. So let's change the north orientation. Let's see that we can change some of that. Get a bit of contrast happening there. So yeah, there we go. Let's utilize that. Go to our F11, and you can see that it will be rendering. And to get an image out of this, if we just hit F10, that will bring up, or that will actually create a screenshot of that particular render, which is quite usable as an image for a quick image. Obviously, creating movies or a dedicated image at a high resolution. But as far as getting a quick image out using your F11 and F10, if I just go find that location where it puts it, there's a particular file location that it, you can see that image now created that image for us, which is quite usable for a demonstration or to add to a drawing, however you wish. So yeah, so that sort of gets us to the point where you've been able to bring model in, do a render, get an image out. So that sort of concludes that first stage of taking information from Advanced Steel to Blender into Omniverse. So now I think it's time to try this other method and show the same workflow, but getting it into Omniverse via Revit, which is has a slightly different use case for an application. However, my preferred method is still using the process of going via Blender BIM, but there will be cases which need us to use the Revit pipeline. So we can go have a look at that process now and show a slightly different take. So let's close this file down. Okay, so we can close those down. We can open up a session of Revit. Right, let's just start a new structural project, and we will use the same IFC files that we exported earlier. So this is one of the beauties of using a neutral file format like IFC that can be used in multiple applications. So we will use the same IFC files that we pushed out into Blender. We'll now bring those into Revit and show how to publish those to Omniverse and how to create a live link. All right, so we've got a session of render open, and we are now just going to bring in those IFC files. So we need to go to that same location where we saved them before. So we're in our sample projects, we're in our CAD, IFC, so here we are. These are the same ones that we used to open up into Blender, and we can now open these ones up. This will take a little bit of time to create the Revit files, or the Revit models I should say. Okay, so we've now got that open. If we come up to our Omniverse here, we can publish this file, and we'll go to the YouTube Revit version here, and we will call it P0042_01. Okay, now let's just close that down. Yeah, we'll close that down. We'll close that down, and we'll create a new project, and yes, we'll do the next one. We might as well do all five. We'll bring those in, and you'll see the slight difference that it has when you bring a Revit file into Omniverse. So we've got that. So we go to our Omniverse publish project, and we will go 0042_02. Right. New project, and we'll do the third one. It's just building the model. Let's just take a quick look here at the resources. You can see now that at the moment we're not using much of our resources at all. So not like when it's trying to ray trace and the GPU is running at full tilt. Right, we're back to our Revit session. It's taking a little bit of time here. This will give you a good idea of how long it actually takes to generate a Revit model from an IFC file. But doesn't take that long, but I think it's quite a powerful process to be able to do, to push our detailed Advanced Steel models into the Revit environment, particularly now that we can push this via a live link into Omniverse. So for a project where you're doing some additional design and you want to be able to do this in a live environment, well, that would be a use case for this particular process as opposed to the Blender pathway. So testing some of these out for different applications, I would say, will determine which is the right process for the right time. It might be that early on in a process or a project you're using the Revit pathway. Maybe towards the end of a project you're using the Blender BIM pathway once you've got your 4D and your 5D BIM data attached to your model and you've animated that. You can't do your animations in Revit, but doing your animations in Blender BIM and in Blender so you can animate your construction sequences is possible. So that would then suggest that the other pathway is better to do this. Just actually taking a bit of time here because it's such a big. Oh, this is the bridge model, so it's quite a large project with lots of assemblies and bolts and folded plates. So you'll just have to bear with me while it loads. Well, thanks for your patience there. We'll just zoom in there to show you what's going on there. So we've got that bridge project in there, and we can now publish. You can export as a prop, or you can publish. You can also turn on this live link, which we can talk about a little bit later on. But let's just publish this like we have done with the others. If I could type, that would be handy. So we're at model number 3. Looks like there's about 5,000 parts there, so it's doing a bit of work there. Okay, so let's do the next one. We might as well, we've come this far, we might as well just keep going. Where are we going here? Sorry, yes, we got to import model 5C number 4. Hopefully this one doesn't take as long as that last one, being a smaller model. Righto, so thanks again for your patience, and we'll publish that one now. So P004204. What this is actually doing, it is creating a USD file similar to exporting from Blender before. Okay, so we've got that one done. We're on to our last one. Importing model number 5. Now this is that residential house, so it's got quite a few elements to it too, so it might take a bit of time. Maybe not as long as the bridge, but it's still quite a big file. Okay, well, thanks again for your patience, and we've now got this 5th model. We'll go to our publish. We'll publish this 042 area 5. So now we're just pushing that model into a OpenUSD format. Looks like it's closed, so we can now close all these down. Let's just close these down. Free up some resources. As we know, the Omniverse is pretty hungry when it comes to GPU. Okay, we'll launch the composer again. Okay, so we're in the composer. We'll just start a new stage, and we'll come to our projects, and we'll come to our YouTube Revit folder, and you can see how it's a slightly different format in that it's created a folder for each one, whereas the Blender project put them all together. So what we can now do is we can bring those models into our stage. We'll just bring them across one at a time. Okay, so now we've brought those files across. Okay, so I'll just zoom in here. So what I've found is that I'm still experimenting with this particular workflow. It doesn't seem to be as robust as the Blender process. You can see how some of the information is missing from these exports, and it would simply be some settings that but what you'll also notice is that it has the ability to also bring some materials across from Revit. So we'll automatically do some of that, where Blender can do that as well, but you do need to set up a few libraries and processes for that to work well. So if we were to look over here at this shed, let's see if I can use my gaming skills here to get to where we need to be. You can see it's added some materials, although these materials aren't great. We can turn on the real-time ray tracing and path tracing here, and you can see how it's brought this across. So yeah, so that is the pathway for Revit. There are still some work I need to do to understand how to get it to work perfectly. You can see here that there are certain things missing. Why they're missing, not quite sure yet, but I did some testing of this yesterday, and it was coming across. So I would say that there is something that didn't have set correctly that was causing that to miss. But I'm sure that can be all worked out. So yeah, so that's the sort of two different pathways to get into Omniverse. I'm sure that with a bit of experimenting, everyone will have different reasons to use different tools to get there. So now that you've seen this in action, where to from here? Well, the possibilities are pretty much endless, and if you've got a wild imagination of what to do with this, then I'm sure there are some pretty cool tools and some outcomes that users will be able to create with the Omniverse. What about myself? Where am I going with this? Well, now that we have a viable, robust drawing automation system in our advanced steel modeling, we've got a lot of BIM data there that we can actually use in these tools like Omniverse, so we can leverage off this structured data that we have created because we have created that environment inside advanced steel. So I plan to take these models and gamify these models and this data to provide a platform for sharing with our clients and with builders, to instead of be interacting only with black and white 2D drawings and PDFs, that we'll be able to give them an environment to interact with our models, ask questions, interrogate our models, and give us some feedback on the design by using a game engine like Unity or Unreal with our BIM data, create construction sequencing, those sorts of tools. So that's where we plan to go with these new applications. Well, okay, that's probably enough information overload for one day. So I hope you have gained some knowledge around what the Omniverse is, what can be done, the process of getting your models out of advanced steel into the Omniverse. Open your eyes up to some opportunities that can exist with these new modern tools. So with that, again, thanks for watching. If you've managed to get right through to the end, thank you, and thank you for your patience. I'm sure this is not going to be a very short video, but yes, I hope you've gained some insights into the Omniverse. Okay, well, with that, remember, if your job's worth doing, it's worth doing right. See you next time.